Hi everyone, welcome back to my Minecraft tutorial. Today I'm going to do lab 2 of physics 2. Okay, the purpose of this lab was to create a more sophisticated model for calculating the electric force on the charged tapes. So I used the electric field equation and the force gravity equation. And I used the Glowstrip computational model. So a brief preview is that the tapes with the same sign of charge will repel. Alright, physics ideas. Okay, so this is a lot of complicated math, so pay attention kids. So I used the dq equals lambda times dl equation. So we're taking small chunks of a line and we're finding the electric field at an observation point. Alright, so yeah. This assumes that the charge is distributed evenly across the bottom tape, and we also assume that there's no air resistance. Then, for each point on the top tape, the dE equation was used to calculate the electric field. This is where you use linear charge density, which is lambda. Alright, so systems and surrounding. The system is the top tape. The surrounding is the bottom tape, and the Earth, which creates an attractive gravity force, and the bottom tape creates a repulsive force. So initial conditions, these are set in the Glowstrip computational code, and I calculated the estimated charge, the mass of the tape, distance between the tape, length of the tape, and constants. Code explained. Okay, so this so the outer for loop, it's gonna pick an observation location on the top tape. The inner loop does what the previous physics principle did, which was just like calculate the electric field along small segments of the bottom tape on the top tape. Okay, so at the end of the code, it's going to create a green arrow, which represents the sum of the electric field from the bottom tape on a specific location. So if we look at this little corner, this arrow points that way because it represents the total electric field of all the points on the bottom tape on that point of the top tape. And then we get to see that the magnitudes do balance out. Alright, similarities and differences. So the model is similar to the free body diagram found in lab, and it assumes the same factors as in the lab, which are no air resistance and that the charge is uniformly distributed across the bottom tape. The calculated charge found in the lab was a little less than predicted by the model to get the force of gravity to balance the electric force. So the charge calculated in this lab was more than what was found in the lab, the actual lab. So this could be due to the tape distance being off in lab. Some of the charge might have left both pieces of tape before we could find the distance, and the tape might have been in motion when we measured the distances, meaning that momentum was not equal to 0. Alright, so what if? The charge found by the point charge model is less than the estimated charge found by the linear charge model. So we can see that the point charge model has almost half as much charge as the line charge model. Right, so why is this happening? So the line charge model is more accurate because it's going to sum the electric field caused by the small chunks of the bottom tape on a specific observation location on the top of the tape. And this results in a better and more accurate number. And then the point charge only accounts for a single electric field vector because we assume that all the charge is in one collective point. So it's only going to create one E field vector, while the line charge model accounts for thousands of E field vectors. And that was basically my lab. Hope you enjoyed. Goodbye.